Okay, so the part that we're going to be doing together are the ones that are highlighted in that bluish color. So what you're going to need for these proofs is all of those ideas about if lines are parallel, then corresponding angles are congruent, and all those different postulates and theorems that we talked about. Okay, and we're going to start off with number one. Number one says, prove that if two parallel lines cut by transversal, then consecutive exterior angles are supplementary. Okay, that is a theorem that we're proving. So you can't use that as a reason. You can't say, okay, well, those consecutive exterior angles, in this case, it's 2 and 7. You can't say that those are supplementary because they're consecutive exterior angles and those are parallel lines. You have to show that that's true using other things besides that theorem because we're proving that theorem. Okay, what's going to be different in this part of lesson 3.2 is that you'll see proofs. So we can use, in filling out a proof, you can use postulates, theorems, definitions, properties, anything that given information, things from the diagram. So anything that we've talked about before is fair game. All right, so our first statement is going to be our given. And so I'm going to mark on the picture here that these lines are parallel, and then we're writing L is parallel to N. The reason is given. Okay, so we're trying to prove that 2 and 7 add up to 180. That means that we want to have another equation that adds up to 180 that we can then plug something into. So you're not allowed to use a 2 and 7 are supplementary, but you can use any other postulates or theorems we've used. So for example, how are 2 and 6 related? How are angles 2 and 6 related?
They're congruent.
Because why?
I forgot. I just know.
What kind of angles are those? Somebody help her.
Aren't they like consecutive or something?
Yes, the C, but it's not consecutive.
Corresponding angles.
Those are corresponding, so they're congruent because the lines are parallel. So for example, we know that 2 and 6 are congruent. The reason I picked 2 and 6 is because I want to be able to kind of swap out 2 and 6, and I noticed that 2 is in our equation here. So if I knew we're trying to prove that measure of angle 2 plus measure of angle 7 equals 180. Okay, so that's where we're trying to get. And I don't know what the reason is yet because we haven't gone forward to get to there. But we know that we need some kind of equation where the two angles out of 180 that we can replace something with something else. So if I knew that I had a measure of angle 6 in my equation, I could take that out and put measure of angle 2 in its place. So that means that if I wanted to just replace angle 6 with angle 2, I would want to say that the measure of angle 6 plus the measure of angle 7 equals 180. Is that true? So look at the picture. Why is it true that when you add 6 and 7 together, you get 180? Why is it true that these two angles?
Because they're a linear pair.
They're a linear pair. So do you know what you write for the reason?
Definition of, would it be like a definition of a linear pair?
It's not the definition, because you're not just saying that the 6 and 7 are a linear pair. You're saying they're a linear pair, therefore they're supplementary. So what you'll write is linear pairs are supplementary. Or you can write if two angles are a linear pair, then they're supplementary. Okay, it's not the definition of linear pair because you didn't just identify them as being a linear pair. You've actually said they are adding up to 180 in addition to being linear pairs. Okay, now I told you that I thought it'd be helpful to use angle 2 as congruent to angle 6 because then I'll be able to just take out angle 2 and put angle 6 in its place. I'm sorry, take that backwards. Take out angle 6 and put angle 2 in its place. So if I know that those angles are congruent, then I would be able to do a substitution. What do I write for the reason why angle 2 is congruent to angle 6? Diamond kind of said it, but maybe not like the whole statement in one fell swoop. what is the reason why angle 2 is congruent to angle 6? So we're saying why
Corresponding angles.
you have to write an if then, because it's only true if the lines are what?
Parallel.
Parallel. So if lines are parallel, then corresponding angles are congruent. Okay, now we're thinking we want to replace angle 6 with angle 2. What will that be when we do a replacement? What is it when you take out angle 6 and you put angle 2 in its place?
Substitution.
That'll be substitution. Okay, so in order to do substitution, we have to get this into an equation instead of having a congruence there, because you can't do substitution when you have congruence and equations mixed together. So this step should say the measure of angle 2 equals the measure of angle 6. What's that reason? What is it when you go from congruent to equality or equality to congruent? What is that?
Definition of congruence.
Good. So you can either say definition of congruence, definition of congruent angles, whatever you want. Okay, so what we just did is showed that if you have two parallel lines, and there are different ways to do this proof, like this is one option, there are actually other ways you could do it as well. But I started by saying I want to show that 2 and 7 are supplementary. So if I can find another supplementary pair that uses either angle 2 or angle 7, and I can do a substitution, then we'll be set. Okay, so that's one way of writing a proof. So sometimes with these problems, there's more than one way. But again, what you cannot do is you cannot use the fact that because they're consecutive exterior angles and the lines are parallel, then they're supplementary. Okay, we're proving that theorem. All right, jump down to the one down here on the lower left corner of the first page. Okay, in this diagram you'll be using for both of the proofs. You might want to copy this before we start writing on it. Copy that and paste it over here. So you have two different pictures for your two different proofs. Okay, this one says you're given the L and M are parallel. So I'm going to mark that on the picture so I know that that was given. And we're given that angle 2 is congruent to angle 4. And I'm going to mark that on the picture so that I know that that's given. That's known information. Okay, as far as writing the statements, those could be written together in the first step, or you could separate them, whichever way you prefer. It really doesn't matter. Sometimes I'll put them together, sometimes I'll separate them, depending on the proof and what we're trying to show. Okay, so notice that we're trying to prove that 4 and 3 are congruent. That means that we would like to be able to say that we could keep angle 4 the way it is, but put angle 3 in place of angle 2. Is it possible to replace angle 2 with angle 3? So what is the relationship between angle 2 and angle 3?
Alternate interior angles.
They're alternate interior. Are they congruent or supplementary, or what's their relationship?
They're supplementary.
Do they look supplementary? Do they look congruent?
Oh, they're congruent.
They're congruent. The ones that are alternate interior or alternate exterior are congruent. Okay, so we were given 2 and 4 are congruent. We can also say because the lines are parallel, that makes angle 2 congruent to angle 3. Okay, and that is if lines are parallel, then alternate interior angles are congruent. Okay, ideas for the next step. We're trying to prove that 4 and 3 are congruent. Sean, what do you think step 3 should say?
Substitution.
Okay, I want to know the statement first.
I don't know.
We're trying to prove that 4 and 3 are congruent. Are we ready to say that? Can I make this angle 4 is congruent to angle 3? Or do we need more steps before we say that?
think you're fine there
Okay. What's the reason?
because the syllogism thing.
Okay. Syllogism is the one that fits like in words. The property, you said substitution originally. It's not substitution because they're congruents. What was the property that goes with congruence that looks like substitution? Somebody help us.
Was it transitive?
Transitive. Transitive property of what?
Congruent.
Transitive property of congruence. Okay, so that's only 3 steps. That will be how a lot of the proofs are where you're proving congruence. So all you need to do is say, okay, this is the stuff we know, mark it on the picture, and then figure out, there's basically going to be one step that leads you, like one thing you have to figure out that will then lead you into your proof statement using, and it's usually transitive with congruence. Okay, so you're going to see some problems like that. You just have to figure out how to connect this one to that one with one step. These are usually 3-step proofs with the congruence ones. Okay, the one you're going to see a similar thing up here. The ones that have the supplementary in it, like we did in the first one's a little bit more complicated because you have to have an equation at 180 and then you have to take another relationship and put it in and do a substitution. So those are a little bit more complicated. The ones you're doing on the first page should all be like 3 or 4 steps. Okay, and then we're going to kind of go back and practice more with the, if you know that lines are parallel, how to find the, how to use those angle measures to make equations. All right, so we're going to do the 2 again that I have like shown there with the blue. So on the first row here, the one on the right side. Okay, we need to find X, Y, and Z. We're going to write down every postulator theorem that we use. So I need an equation first to find either X, Y, or Z. You can start with whichever one you want. Somebody who has not talked to me today. Jerron, X, Y, or Z. Tell me something to do.
I don't know.
What about this right here? What is that?
It's the line.
Okay. So if we add those.
So it would be 2x plus 90 plus x equals 180.
Good. 2x plus 90 plus x equals 180. And that's going to be, I don't want to say that. That's going to be angle addition postulate.
Yeah.
Because we're saying that those 3 angles add up to 180 degrees. Okay, so if we solve that, that's 3x equals 90, x is 30. So we have x. Okay, now let's figure out y. So we know that since x is 30, that means this is 30 degrees. That means this one is 60 degrees. Grant, tell me how to find y.
I have no idea.
These lines are parallel. How are those angles related?
Are they opposite interiors?
They're alternate interior. Are they congruent or supplementary?
Congruent.
Congruent.
Or no, supplementary.
No, they're congruent. So we can say 2y is going to equal 30 because that's what x was. All right. And that's using if lines are parallel, then alternate interior angles are congruent. So that make y equal to 15. Okay, and then lastly for z, so if that one's 30, this one is also 30. Okay, and Derbla, can you tell me what z would have to be?
It would be 150 degrees
How do you know?
because 30 plus 150 equal 180 degrees, which is the angle of a linear.
Yeah, you're using that linear pairs are supplementary. So when you write these equations, you need to be writing down all of the reasons that you're using to get those answers. Okay, that's how I follow your thought process. And then if you make a mistake, I can figure out, oh, you thought the alternate interior angles were supplementary, or something where I can figure out where you went wrong. All right, and then the last one here. So the thing that sometimes throws students off, if you look at this one, and the one down here, when they're shapes like that, sometimes you look at it and you go, I don't know what to do. I have no idea. Like they gave me parallel, but I don't get what that, how we use that. So what I want you to do is think about this as being lines that are parallel that you can stretch out. Okay, and then just use one of those lines as the transversal at a time. For this particular problem, you don't need this line over here. Okay, so we're just going to get rid of it. Just totally ignore it. And then you can hopefully see that you have a transversal here. And then you can make equations from that. Okay, it'd be the same idea on these. You make parallel lines here and then look at just one side of the picture and make that your transversal. And then look at the other side of the picture and make that your transversal. Okay, so it's the same exact thing of parallel lines cut by a transversal and then whatever relationship you need. So if we wanted to find x, we can use an equation to find x. How are the x expressions related? Max, tell me what an equation would be to find x.
Would you do 5x minus 5 plus 4x plus 10 equals 180?
Tell me why.
Because they're they're
Corresponding.
yeah, they're corresponding.
They're corresponding. Okay.
Thank you, Jerome.
Are they congruent
No
or
problem.
Um,
So if you look at these two angles, do they look congruent?
yeah.
Yeah, they're congruent. They're not supplementary. So we should have what for our equation?
Oh, that they equal each other?
Well, right. So 5x plus 5 equals 4x plus 10. And again, what we'll write is if lines are parallel, then corresponding angles are congruent. So we solve that, we'll have x equals 15. Okay, and then if we know that x is 15, we can go ahead and plug that back in. Usually it's helpful to go ahead and plug back in the value if you don't know what the angle measures are. So 4 times 15 is 60, and then that should be 70. And then I'll double check that 75 minus 5 is also 70. So those angles are 70 degrees. Now I need to figure out this y value. So I need an equation that will involve the y expression somehow. Kendall, can you give me an equation to find y?
Would you add the 5x minus 5 and the 4x plus 12 and then subtract the 6y minus 4 and then make it equal to 180.
Okay, let's just kind of forget about those expressions. Remember, we know that these are 70. Okay, we know that those corresponding angles there are 70 and that those are parallel. So I just need to know what this angle measure right here would be. And I don't even think you should worry about that down there. If that's 70, what should that other angle measure be?
But would it be 40?
What do these two angles have to add to? What do these two angles?
180.
180. So if that's 70, that means that one's going to have to be how much?
110.
10. So you can do it either by saying 70 plus 70 plus 6y minus 4 equals 180, or you can just say that 6y minus 4 equals 110, whichever way kind of makes sense to you. Sometimes students like to find the actual number, make that equal, and sometimes you'd rather write that they add up to 180. So what we're using there is linear pairs are supplementary. Because they're adjacent and forming a line, that makes them a linear pair, and we're using the add to 180. So 6y equals 114. Y equals, I don't know, 5419, I think. 5, I think that's right. Okay, so again, all of the other problems that have parallels here, you want to see like one parallel and one transversal at a time. So only look at kind of half of the diagram at once and figure out how those angles should be related. On these problems, you need to make sure that you're telling me the reason. That's part of your answer. Okay, so this right now needs to be submitted to classwork number 9, and then you're finishing that for homework, and that'll be homework number 30. There were only about 10 of you who had submitted homework at the beginning of the period that's due today, so make sure you've done that. If you did not do that at the beginning of class, make sure that gets done, okay? And then I think maybe Grant, I'm pretty sure you did not submit the classwork from last class. I'm not sure if anybody else didn't, but I remember looking that up earlier. Okay, so we will go over the homework assignment that was due for today. We'll go over that tomorrow, not tomorrow, Wednesday, along with the homework that you're doing today. And then we'll do a new lesson, and then you'll have a review day, and then you'll have a quiz on Friday. Right, so have a good rest of your day. Welcome back from break. I'm sure you're all excited to be at school tomorrow.